Hey everyone, welcome back to my Python programming tutorials. In today's video, we're going to be talking about exceptions and exception handling. So before I start on with the lesson, we're just going to go ahead and walk through the keywords that we'll need to deal with exceptions. The first keyword is the try keyword. All you're going to write is try colon, and then within this block of code, you're going to write the code that can possibly throw you an error. So if you see a line of code that can possibly be problematic for the program and throw an error, you should try put it into this try block right here, and then we can later go on to catch the error if something happens. The next keyword is the except keyword, and the except keywords needs to be paired with the try block. So right after the try block, you will tell the program what errors to accept. Right beside this except keyword, you are going to write what error you want to catch. So in this case, I'm going to write value error, but you can write any other exception that Python can throw at you that you want to catch. Now, one thing to note is that you can accept just the base exception. However, this is not good practice because this is the base exception and it will catch absolutely every exception that there is in Python. And this is pretty bad practice because you might be catching errors that you didn't really account for in your code. I'm going to go ahead and give a quick little example as to why you should try and avoid using except exception. So here's the block of code that I've written. It's a simple function called 100 divided by, and all we want to do is try and divide 100 by a number that we get from the user input, which is going to be right here. Here we have the try block, and obviously I've thrown this into the try block right here because, well, there might be an error casting the input to an integer over here. One of the biggest problems that you could see from this input is that, well, you're not really restricting the user from typing in like words, for example, and then you'll have a problem casting it to an integer. So that's why I've thrown this block of code within the try block. So we're going to try to do this code. If it fails, then we're going to jump to the except block and we're going to accept all exceptions. For now, I'm printing your input was not a number. And this code is fine over here and it will work if we call this function and it asks for a number, and let's say we want to divide 100 by 100, and there we go. We get our 1.0, which is correct. However, if we call this function right here and we type in some random gibberish, then this function is going to have a problem casting the input right here to an integer. So it's going to throw an exception at us, and then we're going to catch the exception right here. All it's going to do is it's going to print your input was not a number. However, the problem begins when we try to divide by a 0. Now in this case, you could see it's still printing your input was not a number. However, we've clearly given a 0 as an input, which is a number. Python actually didn't error out over here, it errored out over here. It didn't throw us a value error, which is the error that you would get from not being able to cast your input to an integer. It gave us a 0 division error, which occurred on this line of code right here. That's why it jumped to this except block and it still printed your input was not a number. So as you can see, it was problematic here because we were catching the base exception over here, and the base exception that contains all other exceptions. So every single exception is technically a extension of this exception right here. So if we accept just the base exception, Python will catch all errors and then it will give us the same error message or carry out the same code that we've written over here. A better way to solve this issue would be to catch or to accept both possible errors. So we would try and accept here a value error, and then in this case we would print your input was not a number, and then we would also include another except statement that would catch the 0 division error, and in this case we would print division by 0 error. Now if we run this function and we carry out the same test, so let's include 100, that works fine. Let's try a bunch of gibberish. Oh, and now it prints your input was not a number, which is correct. And lastly, let's try dividing by 0. And as you can see, now we have caught the division by 0 error and we've handled it accordingly. So this is exactly what we want to be doing. We want to be catching or accepting more specific errors so that we can deal with each case individually. This is also good practice because a lot of the times when we are coding, we might want to catch a generic error like this, for example, and then we might want to throw our own specific custom exception. And we will get into that once we move on to object-oriented programming. You'll kind of see how we can create our own exceptions. Now, the next keyword is the finally keyword. The finally keyword is basically a block of code that will execute no matter what happens. So it will execute before the return in the function, and it will also execute after the accept. So if an error is thrown, then it will execute after the accept block of code is executed, But if no error is thrown and you just go to the return statement, well, then it'll execute before the return statement. So if we throw in this function right here, a finally block of code, and then we just print this is the final block of code, then if we execute this function, you could see the finally block will execute just before the return statement. So just before we return 100 divided by, in this case, 1. If we throw an exception, well, then it will execute after the exception, like I mentioned. So right here, first we will get your input was not a number, which is the except block carrying out its code, and then the finally block will execute. Now the last keyword that we're going to be talking about is the raise keyword, and the raise keyword is the keyword that is used to throw errors or raise them. Within this tutorial, I'm going to be using throw and raise interchangeably, as well as catch and accept interchangeably, just because that terminology is kind of used in all languages. Python uses raise and accept. Other languages such as C++ and Java use throw and catch. So accept and catch are synonyms of each other, and raise and throw are synonyms of each other too. So the raise keyword is used not for exception handling, which is this part right here. This is us dealing with exceptions. The raise keyword is used to actually throw an error or give an error. If I were to just execute raise value error, as you can see, Python will throw the value error. Now you can pass in whatever parameters you want to this value error, and it will simply print them out. So you usually pass a string and then you say this is a value error, and there it is. This is value error, this is a value error. The raise keyword is used for a whole different part of exception and exception handling, and now I'm going to talk about the difference between exception handling and exception raising. So code sometimes can have errors that we need to account for. Like we saw in this example, maybe we have a function that accepts a certain type, another type was passed. We need to account for the errors that could happen between casting it and carrying out all the other functionality of the code. So this is called exception handling, meaning we are going to handle any possible errors or exceptions that could happen within that function. And to normally do that, we use the try, except, and the finally keyword. And then we have other scenarios where we might need to throw an error, and this is also part of writing good code. A lot of the times you will be writing functions that other people will be using, and they might not be seeing the implementation to them. So a lot of the times we want to throw an error if something goes wrong. Let's say, for example, we're writing code for like NASA or SpaceX, and a problem occurs on the last line of code. We don't just want to log to the terminal saying, oops, something went wrong, and then the rocket takes off. Instead, we want to throw an error and it will terminate all of the code. That's the good part about these exceptions, that if they're not handled like we did over here with these try and accept blocks, well then the code will simply terminate and it will throw an error in the console, unless obviously we have handled it somewhere within our code. So this brings us to exception handling. Let's say we have a function called one more, and it's going to take in a number and it's simply going to return one more than that number, so just n plus 1. Now obviously the input to this function should be an integer, because, well, we can't add an integer to anything else apart from a float or an int, but preferably the input should be an integer over here. Let's say outside of this function we are going to get user input by saying int input and then give me a number. So this is the way we grab user input, and then we simply want to print one more than the user input. This is our simple little program. All we're going to do is we're going to grab user input, convert it to an integer, and then print one more than that integer that the user gave us. And like I've shown you with the other example, this works fine if the person gives us an integer. However, when that user gives us some gibberish, well, then we get a problem right here, and it's saying value error, invalid literal for int with base 10, meaning it can't convert the gibberish, this string that we gave it, into an integer, which makes complete sense. So we need to figure out a way to deal with this and to make sure that our program is robust and can deal with this edge case right here. So instead of writing this code over here, we should create a function that would get user input for us and return the correct value and type. So I've created this function right here called get user input. We are simply going to loop forever, and the way you can do that in Python is saying while true, because, well, true is always true. So you're going to loop forever. The reason we want to loop forever is we want to keep this loop going until the user gives us a valid integer. So what we're going to do is, well, we need to get the user input, but as we know, this line right here is problematic and it could throw an error, so we want to throw that into a try block. And now I'm simply going to copy this over and paste it right there. there. Now that we've got the user input, let's try to return the user input right here. Now, if this code goes bad, what error can it throw at us? Well, as we saw over here, it can throw the value error. And this is probably the most common error when trying to cast one thing to another. It will throw you a value error if it can't do that and there's some problem between casting. So in the case that we do get a value error, what do we want to do? Well, in this case, we just want to print this is not a valid number. Now this function looks good. The only thing left to do is to account for this code because it doesn't know what user input is. So we can say something like user underscore input is equal to get underscore user input. And we know that this function will now return us only an integer, which is perfect. We don't have to worry about it throwing errors over here. If I type in 10, well, this works fine. We get 11. If I run this and I start giving it gibberish, well, it's simply going to say this is not a valid number, and it's going to ask me for another number. And as long as I don't give it a good number, it will keep asking me for a new number. So once I give it a good number, then you could see it casts it perfectly, and then we will get one more than that number. So again, when writing good code, it's good practice to be catching specific errors as we do over here and not just catching the base exception. That way we know what we're dealing with in the code. So this right here is all part of the exception handling. We are basically dealing with errors that could come our way. We kind of see what is problematic within the code. If it is problematic, well, then we throw it into a try block and then we try and execute that code. If it doesn't work, then we figure out what error it throws us and we try and accept that error and do something in the case that it does throw us an error. So this is all part of exception handling. Now on to raising exception. As mentioned, sometimes we do want to throw errors to terminate the program. So I'm going to give you two examples as to where we should throw errors. Not always will people using your code have the source code in front of them. They won't always be able to see what your code is doing. So a lot of the times we will have to write functions that will throw errors in case something goes wrong. As I mentioned before, exceptions, once they're thrown and they're not handled, they will terminate the program there and then. Let's say we have this method right here that is called 100 divided by, and then it takes an input parameter of n and it tries to divide 100 by n. In this case, let's say that we already have a function that's getting user input, and the only thing passed into here could be integers. So values from like negative infinity to positive infinity that include 0 as well. So as you know, division by 0 is problematic and Python can't do it, and it will throw you a 0 division error. This method would work perfectly fine until we get n equaling to 0, and I can show you that if I run this and I run the method, it will work for every number except once we throw it 0, we will get an error right here, and this is exactly what we want. I know this example is going to seem a little redundant, but it's kind of good to know why and when we should throw these errors. So just bear with me on this example. The next example I'm going to give you is going to make a little bit more sense. So let's say we want to deal with this scenario where n is 0. There are a couple ways to do this. One of the ways to do this is we could try to return this block of code right here like that, and if this were to throw an error, we can just say accept 0 division error, and then instead of just printing to the console, we want to throw an error to terminate the code, because let's say this was on the last line. Well, we don't want it to launch if all of a sudden we get a 0 here, so we don't want it to print and then just continue. We want the program to terminate, so we're going to want to raise a 0 division error, and I'll actually add this string in here, hello, just so you can see that it is this error being thrown. If I execute that with 0, there is our 0 division error being thrown right here with the string hello. Obviously this is super redundant because we are accepting this error and then we are raising the same one with a new string. However, this sometimes does make sense when you want to throw your own custom exceptions, so just keep that in mind, that sometimes you might want to catch a super generic error and then throw your own custom one. But again, this is redundant and there's probably another way to do this. And I think the better way to do this is to check before we actually do the division. If n is 0, well, in that case, we want to raise the 0 division error. And again, I'm going to include the string hello just so you know that it is our exception being thrown. If this exception is not thrown, well, in that case, we want to return 100 divided by n. So now if I run this method and I include 0, well, you could see that our error is thrown right here because n is equal to 0, and this is exactly what we want. Now, of course, in this example, you really don't need this block of code just because this by itself will throw you that error. I was just trying to portray to everyone why it's important that we need to throw these exceptions sometimes. And it's also important to note that we don't see the implementation of this divided by. We know how to use it, but we don't know what's going on in the background. And that's exactly what coding sometimes is. You can sometimes be writing functions or methods for people, and they will be using it without seeing your implementation of the code. So it is your job as a programmer within that method to deal with all of the possible edge cases that could happen. Like if the user's using your function wrong, well then it's your job as the person who wrote the function or method to throw the appropriate errors if the person is using your function incorrect. Another place where we would want to raise an exception, and this is pretty common within code, if we're writing a method, let's say we're writing this 100 divided by method, and a lot of the times what people will do when they're starting a project is they will write out all the methods that they'll have. There will be a lot of them, and perhaps they don't want to implement some yet. Maybe they want to like debug their code for a little bit. They'll have a bunch of these methods or functions, and then they'll leave some unimplemented. And in Python you can just include pass over here, but let's say this function is being used somewhere down the line of your program and you just have a simple pass, so the function will quite literally do nothing. A lot of the times people will get headaches debugging this code because they'll be like, oh, what's going wrong? And there is a unimplemented function being used within your code and it's somehow running. What you want to do is just want to raise a not implemented error. So you'll just want to keep it like this, and this in my opinion is a little better, especially on big scale projects, simply because if this function were to ever get executed, well then you know, hey, within my code I forgot to implement this function. I should probably go and do it just so I can debug the rest of my code. So yeah, that's it for this lesson on exceptions and exception handling. Again, there are two separate notions of this. There's exception handling, which we'll use the try, except, and finally block. And then there is the raising exceptions, which is what we sometimes want to do when we're writing code for other people or writing our own method. Hopefully you guys have enjoyed this video. If the video has helped you out at all, please like and comment as to what I helped you out with. Like usual, if you're new to this channel, please like, comment, and subscribe. It's greatly appreciated. And yeah, I'll catch you guys in another video.